Hi all, I am Dr. R. Harinisree, Assistant Professor and Head, Department of CA and IT, Kamadena Arts and Science College, Satyamangalam. In this presentation, we are going to see about data structures, graph. So this is the introduction of graph data structure. Graph data structure is a non-linear data structure consisting of vertices and edges. It is useful in fields such as social network analysis, recommendation systems and computer networks. In the field of sports data science, graph data structure can be used to analyze and understand the dynamics of team performance and player interactions on the field. So this is the representation of graph. So in this graph we have nodes or vertices and edges. So this is the advantages of graph data structure. Graph data structure used to represent a wide range of relationships. As we do not have any restrictions like previous data structures, trees cannot have loops and have to be hierarchical arrays, linked list, etc. They can be used in model and solve a wide range of problems including pathfinding, data clustering, network analysis and machine learning. Any real world problem where we certain set of items and relations between them can be easily modeled as a graph, and a lot of standard graph algorithms like BFS, DFS, spanning tree, shortest path, topological sorting and strongly connected. Graph data structure can be used to represent complex data structures in a simple and intuitive way, making them easier to understand and analyze. So these are the components of graph data structure. First one is vertices. Vertices are the fundamental units of the graph. Sometimes vertices are also known as vertex or nodes. Every node or vertex can be labeled or unlabeled. Second one is edges. Edges are drawn or used to connect two nodes of the graph. It can be ordered pair of nodes in a directed graph. Edges can connect any two nodes in any possible way. There are no rules. Sometimes edges are also known as arcs. Every edge can be labeled or unlabeled. So this is the difference between tree and graph. Tree is a restricted type of graph data structure just with some more rules. Every tree will always be a graph, but not all graphs will be trees. Linked list, trees and heaps all are special cases of graph. So these are types of graphs in data structure and algorithms. First one is null graph. A graph is known as a null graph if there are no edges in the graph. Then second one is trivial graph. Graph having only a single vertex. It is also the smallest graph possible. So this is the trivial graph. So these are the representation of null graph and trivial graph. Then third one is undirected graph. A graph in which edges do not have any direction. That is, the nodes are unordered pairs in the definition of every edge. Then fourth one is directed graph. A graph in which edge has direction. That is, the nodes are ordered pairs in the definition of every edge. So this is the pictorial representation of directed and undirected graph. Then connected graph. So the graph in which from one node we can visit any other node in the graph is known as a connected graph. The next one is disconnected graph. So the graph in which at least one node is not reachable from node is known as a disconnected graph. So this is the representation of connected graph. So all the vertices are connected in this connected graph. Disconnected graph means there are no connections between 5 and 4 these nodes. So next one is regular graph. The graph in which the degree of every vertex is equal to k. K is called regular graph. The next one is complete graph. The graph in which from each node there is an edge to each other node. So this is the representation of complete graph and k regular graph. Next one is cycle graph. The graph in which the graph is a cycle, it itself, the minimum value of a degree of each vertex is 2. Then next one is cyclic graph. A graph containing at least one cycle is known as a cyclic graph. So this is the representation of a cycle graph and cyclic graph. Next one is directed acyclic graph. A directed graph that does not contain any cycle. Then biparated graph, a graph in which vertex can be divided into two sets such as the vertex in each set does not contain any edge between them. So this is the representation of these graphs. Then last one is weighted graph. A graph in which the edges are already specified with suitable weight is known as a weighted graph. Weighted graphs can be further classified as directed weighted graphs and undirected weighted graphs. So this is the weight. So between 5 and 0 nodes we have 10 as weightage. Then these are the real life applications of graph data structure. Graph data structure has numerous real life applications across various fields. Graphs allows random connections between nodes, which is useful in many real world problems where do have restrictions of previous data structures. Used heavily in social networks, everyone on the network is a vertex or node of the graph, and if connected then there is an edge. Now imagine all the features that you see, mutual friends, people that follow you, etc. can seen as graph problems. Used to represent the topology of computer networks such as the connections between routers and switches. Used to represent the connections between different places in a transportation network such as roads and airports. So these are the simple representation of our graph in the data structures. Thank you.